And so again, we're going to prove this. We'll prove by induction. And remember the base step or the basis step. And now, again, one thing to, so since it's for all n, like our starting point, you don't always have to put this n naught down, but your starting point is going to be 1. And then when you put this base step or basis step, you can either say n equal 1 or n not equal 1. Books use it in different ways. It's good to kind of get used to both ways. I'll put n equal 1 here. So in this case, the question is, so we're going to put that into our function. 1 cubed plus 5, 1 equals 6. And then we have to ask the question, is it divisible by 6? And obviously it is. And then do the induction step. And we assume is divisible by 6. Want to show, again, so we want to show that n plus 1 is divisible by 6. We replace everything we have here with n plus 1 cubed plus 5 n plus 1 is divisible by 6. I said before that we usually start with our assumption and try to prove everything but for these divisibility problems, you usually want to start with what you want to show. You want to start with this and show it's divisible by 6. So again, like I said, almost all the others will start here and try to show this, but with the divisibility problems, usually easiest to start with this because we're just assuming this. Now we want to show that this is divisible by 6. So I would start from here. And so we want to show this is divisible by 6. So usually what you want to do then in these cases, see if you can somehow work this out to get your assumption to show up. Because then if your assumption shows up somewhere down here, then we can use that. So let me, and we'll probably have to expand this. And so I'll go through all the steps here just to be sure that they're all correct. So I'm going to expand. So if we want to cube this, I'll square 2 of these. So n plus 1 squared will give us this. And if we multiply that by n plus 1, and over here, this would be 5n plus 5. And then do this foiling or whatever. Some of you maybe memorize the trinomial equation. I never did. I always multiply them out. And so, but if you memorize it, that's even better. I usually go ahead and just work them out. And then plus our 5n plus 5. And then let's try to combine some things here. So we have an n cubed. And then let's combine all of our squares. We just have those 2 squares, 2n squares. Then if we want to do the n's, so it'd be, it looks like 8n And then if we add our constants, looks like 6. And you know what? Let's see. Yeah, okay, I think that's right. So now, let's see here. So what we want to do is try to get our assumption to show up. So we would like to somehow get, oh, sorry about that. Try to get our assumption to show up. And let's see, what could we do to get our n cubed plus 5n? We could really just rearrange things, huh? We could just maybe take some out of the 8n and move it over here. So let me take, so in other words, I'm looking to try to get this. And so let me just kind of move these around. So we have n cubed. So I'll bring this 8n over, but I only want 5n. So let me take 5 of these and leave 3. So I'll take out 5n. And so I move that over here. Then I'll kind of move this over here. 3n squared. And then I'll leave 3n here plus 6. And then let me put a plus here. A little bit messy. See if that makes sense. So all I did was kind of, I wanted to end up with, I want to have a 5n here. I have an 8n. So I took 5 of those 8, put them here. 3 of the 8, put them here. Move this over just so I could have this. Because I know that's going to be divisible by 6 by our assumption. And then the question is this stuff over here? So this is divisible by 6. So, but let me go one more step here. So the question is this mess over here divisible by 6? There's probably a couple ways we can look at this. Let me factor this out. 3n plus 1 plus 6. So obviously this is divisible by 6. So if we can get all of our terms to be divisible by 6, then the whole thing will be divisible by 6. So this is divisible by 6, divisible by 6. And let's see, how can we argue, what can we say about this term here? Could we somehow say, do you have an idea? This is always going to be even. So if you have 3 times an even number, you're right, then that's going to be divisible by 6. Because if you have n times n plus 1, that's going to be, one of those is going to be odd, one is going to be evens all the time. They're always going to have one, and then an even times an odd is always even. So you're going to have 3 times an even number that has to be divisible by 6. So we've proved, so n cubed plus 5n divisible by 6 for all, and in the natural numbers. Any questions on that? So we did the base case. We were allowed to assume that this was true. Then we went here and showed that this was true. Any questions at all? Let me see. We have almost the same. Oh yeah, let me do another one here. There's no question on that. Let me do another one of these divisibility ones. Prove that 5 to the 2n minus 1 is divisible by 8. All in the natural numbers. So once again, we're doing all n. So that means that like our starting point and naught is 1. And then our basis and equal 1. So again, just put this, put the 1 in here. Minus 1, and that's going to be what, 25 minus 1, 24 divisible by 8. And so once again, do the induction. And remember, with induction, we're allowed to assume that 5 to n minus 1 is divisible by 8. And we want to show five, 2, and then we replace n plus 1 minus 1. Let's multiply that out. The 2n plus 2 is divisible by 8. And like I say, once again, for these divisibility problems, usually start with what you're trying to show is divisible by the number, and then work with that. See if you can somehow work the assumption in. So this one, so we want to start, oh, excuse me, there should be a minus 1 here. Please fix this. There should be a minus 1 right there. So that's what we're trying to show. Right there is divisible by 8. So let's see. This one's just a little bit trickier because we're trying to get this into it. So so again, we'll start with this, and let me just rewrite this as 5 to n to the 5 squared minus 1. So we're trying to work this, make this show up here somewhere. And looks like that's going to be kind of hard. Now, we could make this appear here if we could factor out this 5 squared. If we factor out of here and factor out of the here. But unfortunately, we can't take a 5 squared out of here. So we can take it out of here, but not out of here. Is there something you think we could do to maybe make a 5 squared show up where that 1 minus 1 is? 22n. I'm gonna put all the steps in so everyone can see. So we'll put minus, just what you said, minus 24. And then 5 to the 2n, 5 squared minus 25. 5 and 5 squared minus 5 squared, like that. And just like Derek said, subtract, oh, not, and of course, I'll add 24 here. Sorry. You're wondering where's that magic coming from? And add 24 here. And then now we can factor, like Derek said, by subtracting this 24 and then adding 24. Of course, we're allowed to do this because we're just adding 0. We can factor out the 5 squared here. 5 to the 2 and minus 1 plus 24. And then, of course, this is divisible by 8 again. And then so we've proved our induction. 2 and minus 1 is divisible by 8 for all n in the natural numbers.